Okay, so today we'll talk about the automation EV charging applications. As Dr. Narayanan sir explained, myself Mahadevan. I'm working as a manager and team leader in the known as Technology Business Center India Private Limited, Mahindra City. So we have a plant in Varagadam. So that is a manufacturing facility. But what we are doing here is the full of engineering service and solutions, and not only product development, even IT solution also we are doing globally. From here, we are supporting to China and even North America, Brazil, and many countries. We are doing a remote engineering work. Okay, that's all about my background and my work. Okay, let's start about the introduction to electric vehicles. I don't want to bore you much because in these days you would have seen many introduction, many people give an introduction about electric vehicles. I don't want to bore you much. Just I will give you some small glimpse and then we can move fast in this automation area. So everybody knows today trends is towards the electrification for the more of vehicles. For any trends, there will be a positive and negatives. I won't say it's a negatives. We can say it's a challenges only, because we need to have a challenge. With this challenge, we can do more innovation, and through advanced technologies, we can overcome the challenges. We can say what all the challenges we can say in terms of electric vehicles. The first one is the expensive vehicles and infrastructure. Of course, since we are in the OEM, automotive OEMs, we know very well almost a 40% cost of the vehicle is EV vehicle is the battery only. So still we are facing difficulties to control the cost. So we need to have a different batteries to control that. And in infrastructure also biggest issue, not only in India, even Europe also we are facing a biggest issue, because whereas in a country like North America, there's a big landscape. There they are facing the biggest challenge in terms of infrastructure and negative effects on the grid. Yes, if everybody started using the electric vehicle, then everybody will be charging the vehicle in the night time, then there will be a huge demand between power generation and supply. So this will give a negative effect to the grid, and it's difficult to control also. This is one of the challenge we would say, how to control that. This is somewhat addressed nowadays with some positive area. We can see that I will explain later. And battery degradation also one of the issue, and it's a different type of battery we are all overcoming, but still there is a challenge. And security issue also there for any electrification, that also we are overcoming with some advanced technologies. Main thing is the range annexity. So kilometer is the biggest challenges. Even nowadays, when we started the electric vehicle in India, even globally, they say 100 kilometers per one charge. Now it is become in India, it is even for Indian vehicles, it is almost 200 to 250 kilometers. But in Europe, they're covering up to 450, almost 300 to 450 miles they're covering. Almost it is 600 kilometers, we can say. But even considering the landscape, I mean, big area of the landscape, but it's not viable for them. And for India case, it's okay, but still we need to improve further. And long time to the charging is the biggest challenge. Now we have a different fast charging method also is there, but still we have a long time charging. It's one of the challenge. In positive side, we can say efficient electric motor is the biggest plus, because IC engines always has the energy loss in terms of thermal. So the efficiency will be 60% only. Sometimes it will be less, depends on the fuel type. And there is a less noise compared to the IC engines. But initially it was a huge noise, almost equal to the petrol engine for the EV, but now it's all controlled with some good improvement in the electric motors. And next one is the zero tailpipe emission. The reason why we are telling zero emission at the tailpipe, it's only at the tailpipe only, but really we are not achieving the emission, zero emission, because to achieve this, to produce this power, just in different way, we are using the fossil fuels. So it's clear that we need to use the renewable energy sources. Maybe there we need to have a more focus. Next one is the contribute to the grid. Yes, of course, this is the answer for the negative effect on the grid. So here we can achieve this through these bidirectional charging method. For example, vehicle to grid and vehicle to home, vehicle to vehicle, and through this bidirectional charging method it is possible. Even the battery swapping charging station, it is quite possible. Since battery is always located in the charging station, so anytime it can contribute to the grid to provide the demand in the grid. And decreasing in the pollution in cities, yes, cities like Delhi and Chennai and maybe metros like Bangalore, the pollution is always high because of the high dense of vehicle. So if you have a EV, then definitely you can reduce the pollution. For that, the money is not a matter. You can't compare with any other matters. So pollution is an important one. It's directly linked to our next generation. So next we can talk about the Indian roads and what is the presence of vehicles in India. So at present, Tata Motors, they have almost 4 vehicles, and even today, this year Auto Expo, they've shown many vehicles in upcoming range. Mahindra also, they have some vehicle range like XUV 400, e 2 and the thing. And Chinese player like BYD and MG, they have vehicles in the Indian roads, especially for the two-wheelers, two-wheeler players like major players like TVS, Bajaj and Ola and other bikers. So they introduce many vehicles. Now it's clearly visible that and there is a need of reliable access to the charging infrastructure. It doesn't mean that we need an infrastructure. We need a reliable access to the infrastructure. So since a vehicle is coming up in our road day by day, so we need to have a focus more on it. Let's talk about the charging station. So here also the electric charging, mostly it is called as the EV supply equipment and EV charging point also. Sometimes it's EV chargers, you can say simply. So mostly the purpose of EV charging station is the energize the battery with some clear communication and intelligent and efficient communication with some clear safety measures. So this is the intent of the charging station. So if you go for the charging method, we have a conductive and inductive charging method, and we have a battery swapping also. So in that, we have slow charging and fast charging. Mostly all the AC charging will be slow charging, except the Tesla. Tesla is always exception because with technology they are playing in the globe. They have the 43 kilowatt fast AC charging. Almost all the AC, DC charging is a fast charging. Even we have some ultra fast charging also. We have it will provide up to 150 kilowatts, but in general, so what we have in the market is a 50 or 25 kilowatt only. Now you can see the illustration nearby, the BPCL petrol bunk, the picture I pasted here. This is nearby our university, Saram University, Katangulathur, BPCL petrol bunk, where we can see it has the charging station. It has the 25 kilowatt DC fast charging, and it has a connector of CCS type 2. So about the connector, we'll see in upcoming slides. So this is the limitation we can say. So if you go for the charging, we have, as I explained in previous slide, we have a conductive, inductive, and battery swapping. In the conductive itself, we have a static and dynamic, and inductive also we have a static and dynamic. If you go for conductive, we have a manual method in static, which is a normal method. We have to plug in, plug out by end user. And there's also scope for some improvement where we have a magnetic connectors to have a common connectors, but still we need to have a lot of improvements and research in this area. But next one is the automation. This is the area we are going to focus today. We are going to discuss more about this in this area. We can see many what is there in research level and academic level, what is in the market level. Both we are going to see today. And for the conductive, we have another method type is there's a dynamic, of charging while go. In this case, we have a bottom up and top down method. Bottom up mean from the road we can charge, and top down is something like our urban electricity train. It both has the safety issues and as well heavy investment for the infrastructure as well. Whereas if we go for inductive, it is something like wireless charging, that we have a static and dynamic. Even for the almost it is something like the futurist one. Almost the future of EV will end up here only, because we need to have more convenience and comfort everywhere. So definitely we held up with this inductive. More research is going on this area. Whereas now in conductive, automation in the static charging will be a bit easy because we are not doing any changes in the vehicle. Whereas here in inductive charging, we need to have some alteration in the vehicle for the receiver of the charging pack, charger. So that is the biggest challenge. So in terms of inductive charging, we have a static and dynamic. In static is simply, I mean, we have a charging pad at the parking slot where you can park the vehicle. It will get charged automatically. Something like the wireless charging, what you are seeing in your home or in the car. I mean, for mobile, it is not something like. But there is a difference. I mean, between those, there is a no connection between the vehicle and the charging pad. You can see that even though we have some issues like alignment issues, and if you don't align properly the vehicle, then charging would be effective in terms of static. And if there is any presence of foreign particles like steels or some metals, then it will be a big cost to the dangerous cost to the environment, and as well as the vehicle and as well as passenger also. Reason here, in normal power, we have 50 hertz frequency. Here they are converting 50 hertz to 85 kilohertz. Just imagine, from 50 to 85 kilohertz. So because of the heavy frequency increase and transformation, because of the magnetic resonance, the EMF being introduced in the receiver at the vehicle, and because of the EMF induction, the electric energy is being produced in the coil and it's being charged in the battery. So this is the basic fund of the static charging. Whereas dynamic charging is similar method. Is something like on the go we can charge. Something like green roads. So maybe in future we may have some green lanes for the electric vehicles. On the way, just we can charge. The same methodology only we are going to follow here. They are going to follow here, but there is a limitations here in terms of speeds. We have to keep the speed for the 10 kilometer per hour. I could see some of journals. They mention very clearly. If you cruise a vehicle, not cruise the vehicle, if you drive the vehicle, I won't say it's drive the vehicle, have to creep the vehicle. So just we have to creep like a snake. So you have to creep the vehicle with 10 kilometer per hour, then the charging will be effective. Just imagine if you want to charge your vehicle for 1 hour, then you have to travel in this road by 10 kilometers, then you have to pave the green road for the 10 kilometers. So definitely it's a huge investment. It won't be a effective solution and maybe in future. As I said, in India also, we have some new policy for the released by the government, state government and both the central government. They are going to build the infrastructure of EV for the both side of national and state highways in between within the range of 25 kilometers. So every 25 kilometers once we can see the charging station. Maybe in between this charging station, this greenway could be effective one, maybe for 1 or 2 kilometers to charge the vehicle. Is something like a supplementary solution. It cannot be 100% solution. Maybe it may change in future. And if you talk about the battery swapping, it is not full effective for the four-wheelers. Only for the two-wheelers we could see in India in some areas. But the only thing is here only the very small and a few type of battery can be kept in the store because of the space consumption. Moreover, in main cities in neck area, we need to have a big space for that. It's one of the negative effect, negative say. And another biggest plus is the contribute to the grid. Since the batteries are always in charging position at the station, battery swapping station, here by means of the dual, bidirectional charging, contribute to the grid is quite possible. So the load can be managed in the grid. And here the monthly rent or the lease of the battery could be additional expense to the end user. So these are all the charging method and what are the plus and minus. So now we'll focus more on the automation, on the static conductive static charging, and how what is the automation level of automation level today. So before that, just I want to give some intro about the what are the different modes is being used in the static conductive charging. So we have 4 modes: mode 1, 2, 3, and 4. Mode 1, it's mainly for the directly something like a home answers type. From the home, you just directly can connect. Next one is with the control and communication, and third one, the mode 3, it's mainly for the charging stations where you can see. The fourth one is mainly for the DC fast charging, where you can control efficiently, and it will allow the very fast charging speeds. So these are the different modes of the charging. And this is a major topic. You can see the different socket type. So this is the biggest challenge. We have many types. So first one is the socket type 1. And this is mainly for the low power charging. It's up to 7.4 kilowatt. It's only in the single phase. Whereas socket type 2, it is mainly used in almost all the charging stations globally. I mean, in the US also they are using this kind of charging. And next one is the socket type 2 with some combined charging system. You can say even CCS, we can say CCS2. You can say additional 2-plex for the fast charging. Here, through this CCS, we can achieve the DCS, I mean, DC fast charging. It's up to 50 kilowatts. And even for the type 1 also, we have with the type 1 plug, we have additional 2 plug. This is called as a CCS1. So basically, the type 1 and type 2 plug is extended with the additional 2 plugs as the CCS1 and CCS2 globally. And another one is the GBT plug. It is mainly used in China, most of region in China, almost in the China. Even India also have been using this. It is something like the inverse of type 2. So mostly we are playing it by type 1 and type 2 only. So here it is the inverse of the type 2 charger, and it's mainly for the single phase AC charging. The connector also has a 7 pins like type 2 connector. It's only 3 pins only being used and 2 pins for communication, and the remaining 2 are simply unused. So this is about the charging, mainly main types. And another one is the socket type 3. It's very rarely used, but still some of terminals equipped with this type 3. But I could see this kind of terminals, I mean, in the Europe, mainly for the vehicle sharing. So it's very old type. Still, they are following that. They don't want to stop that. Just they are continuing with the vehicle sharing. Anyway, anytime you can take your vehicle, something like a cycle. So you can take your EV and charge in other station. So for vehicle sharing, they are using this kind of one. It's very old method. The type 4 is the either type 4, I can say CHAdeMO. That means charge the mobility. That is the meaning. Mainly it is being developed by Japan, and mostly it is exist in Japan and in some few countries nearby. With this 50 kilowatts charging is possible with the DC. The other one is the major player in North America, USA. They are exceptional every time. See, the connector type is totally different. I can see that is totally different one, but they know the global compatibility, so that they are giving additionally with some J1772 connector with the holder itself. So it can it can fit to the almost all the charging stations in the USA, and maybe it's I mean, it's something like type 2 only. So with this adapter, they can connect outside of the world also, outside of the US also. Mostly, I mean, it's a type 1, sorry, not a type 2, it's a type 1 adapter they are giving with the default. And moreover, in their online shop itself, they are giving adapter for CCS1, what I explained in earlier, the combined charging system with type 1 connector. So for that also, they're giving adapter to the Tesla adapter, something like what we are using nowadays, the same kind of adapter. And even for type 2 also, they're giving adapter in their online shop. So we can charge anywhere this Tesla vehicle globally. This is one of the plus. So this is all about the different type of connectors, what is there, and the charging method. Now we will go to the EV policy. The reason why I'm insisting here the EV policy, we should aware. So what is the in which era we are, and what is the plus we have and minus we have. Here fully about the plus, what is the benefits and incentives where we are going to get in nowadays. This is the latest one released by the government of Tamil Nadu for the new EV policy. We have some highlights that I want to mention here. You can see the attachment here, and maybe you can download the Google anywhere. You can see that. Just I want to give some few glimpse. You know very well, if you are living in an apartment, you know, you can understand easily. For your only for domestic application, for your home application, the tariff is normal. For your common charges, like your maybe for electric, I mean for your normal borewell pumps and the common lights, what we have the extra, I mean the service. It is for that the tariff will be a commercial tariff. Maybe you would have some of them face the issue, but the government has taken the charge. Only for the domestic use, the exact to the home, it will be a domestic tariff. Otherwise, if it is a common use in the apartment, it will be considered as a commercial tariff. It's all changed already. Now there is a flexibility. If you have the electric vehicle, and if you want to charge at home, maybe at your car parking area, for that you can get a separate connection, and the tariff will be same like domestic charges. This is one of the plus you can say. I don't know how long they will give, but this at the moment it is available. If anyone has the electric vehicle, this is because good news for you. And another one is the supply for the charging stations. They want to promote everywhere, so that is the reason. Even for the battery swapping station, they are they are given the tariff of high tension tariff of type, classification of 5. You can see that I mentioned the table here. If you use the if you have any charging station, or any investors, or investor have the battery swapping station, for them they have to pay the based on their kVA, the load, and they have to pay the 300 rupees per month for each kVA. These are demand charges, and the tariff will be 9.5 rupees for the charging station, for the public and private charging stations. Now, for as an incentive purpose, they are giving in the demand charges, they are reducing by 70% for first 2 years, and further 50% for next 2 years. And even for the energy charges, they are going to reduce. Already they announced that there will be a 50% reduction. It's not a 9.5, it will be 4.2 rupees, 4.25 rupees per unit, only in the non-peak hours. Peak hours nobody will give, because already they implemented the peak hour charges. Now it is started in India also, because of the high population and huge demand for the electric power. So in non-peak hours, if we do that, then we'll get the 50% reduction. So these are all benefits, incentives we are getting for the EV. So, and moreover, even for the charging station, to promote the charging station, government is giving incentives. So for the fast charging station, they are giving up to 10 lakh incentives for the first 200 investors. And first slow charging station, they are giving incentive of the 1 lakh incentives. It's not only a matter of this one, and even for the taxes on the service, it is fully free. So this is one of the major. There are many subsidies are there in the policy. You can see clearly for this for the slow charging. First 500 investors they're giving incentives. So by seeing that, in future nearby, within down the line by 3 to 4 years, you can see many charging stations across the road in the Tamil Nadu. So it's very clearly it's visible that we need to have some advancement in the charging station. It doesn't mean that if everybody use the same charging station, there is no meaning at all. So we need to have some automation to attract the customer, to give the comfort and convenience to the end customer. So that is a major one. So here it's play the automation. Even nowadays, if you go for any petrol bank, what do you expect? In earlier days, just you find the petrol bank, you just will fill up. Now it's not like that. We are expecting some additional services, and we'll see how the location, is there any additional facilities there or not. So obviously, if you have a more charging station, definitely end user will expect the automation. Now we'll see the automation. So as I mentioned here, there is a clear visibility for the charging station, and it's a dedicated parking slot at all the mall, office, and even motels and service apartments. So there we need to have a charging station. And moreover, the conventional plug-in charging methods need more involvement of end user, where they need to carry the connectors. Almost it is 1 to 2 kg. It depends on the connector type. So it is a to the end user. So this is also one of the reasons why we need to go for automation. And so by seeing that all, and in future there is a clear need of automation to ensure the comfort and convenience to the end user, and moreover it is a basic need of any technology or innovation in the modern days. Without these, we cannot move up. Otherwise, if you don't move up, we won't get a mobile in our hand. Still we will be sitting with our old table phones, but now we moved up. So that is the reason we need to move further with the new technology and innovation. Definitely automation is needed for the EV charging. Okay, so now we'll talk about the few automations in the EV charging area. First, we'll see some of institutional level automation, how it was started. Just I can say like that. Something whatever I mentioned here, lens. It is something initially it was in research level, and it was in the institutional level. Now I will, after this, next I will show you what is the current trend, what is the technology advancement, what is there in the product level, what is there in the concept level. Now we'll see only the institutional level and the research level, what was there in lost. You can see that. So there is a security robot is being initially developed. It is mainly for the supervising purpose. You can see here, this will do only supervising and we do some visual job. And this is a charging station. I mean, sorry, it is a home location or docking station. So for this robo, the docking station is the home location. The robo will back to the home location or docking station in two conditions. Either the power is getting reduced in the robo, or the server line's work is over. Either in two conditions, it will move back to the docking station. And moreover, this docking station, they provided with 2 mm tolerance and some 5-degree tolerance in terms of angle. And there is a spring load also. When we docking, it should ensure the effective docking. So for that, this is the docking mechanism. It's shown this. I took it from journals somewhere. And here about the docking station, there is a blue navy circle is given here because this is a signal to the robo. So it has the camera. So the blue navy circle is located just above in the camera level of the robo. And whenever it moves on the other area, once work is over or it need a charging, it will move. It will search to the robo knows the what in which direction it was moved. It has in the memory, and moreover, it will move to the orthogonal angle of the position, and it will rotate to the 90-degree and will straight away reach the docking position. So this is how it works. This is the initial level of self-docking robot they made, and we'll see next one is the cable-driven auto charging. It's a robot. It's something like a normal. If everybody drive the normal car, would have understand this. So we are using a cable-linked mechanism for the gears to shift the gears. First gear, second gear, third gear. It's all linked by the cable operator, cable actuations. The same way, it's something like reverse method. Here they with the help of cable actuation and servo motors. I mean, they are achieving this. You can see that there is a series of 6 permanent synchronized motors, permanent magnetic synchronized motors, and it has the 3 degree of freedom. I mean, 3 axis it can move, and it have 6 motors and 6 cables, and there is a vision sensor also and encoders, and moreover they have a load cell. It's a different reason. Since it is being fully worked with the cable driven, it need to check the cable tension. So cable tension is one of the biggest issue. If the cable tension is somewhat it's differing, then it's difficult to control the motion. So for that, they have a load cell to measure the tension of the cable, but it is not the link to the feedback. I mean, this feedback is not closed one. It is not again connected to the servo motor. It's just they are observing the load cells. Through load cell, they are observing what is the cable tension. And they have a moving platform also in the down, just to move in a small direction with some additional one length motor. So we have a 3 degree of freedom. Additional, we have a 2 degree of freedom. Totally 5 degree of freedom. Robotic charger here it is. It's all driven by the, as I mentioned, cable driven. Okay. Moreover, they have the ATI FT sensor to measure the interaction forces and torque during the plug-in and unplugging process also. So they are used here the industry personal computer for the integrate of the to all the process. So they use the IPC only. A simple mechanism they made for the charging. And next one is the agricultural EV. So autonomous charging station for agricultural EV. So at least for the normal electric cars, it is easy to manage because we have a selective type of connectors like connector 1, type 1, type 2, type 3, and even with combined 1 and CHAdeMO and GPT, there are many things are there. But whereas an agricultural vehicle is difficult because we have a different manufacturer for the this kind of agricultural EVs. So they will go with their own library product It is difficult to control them. So there is one solution to overcome this all. We have a common gripper with some autonomous charging station. So it's a combination of Holomonic mobile platform. You can see that this is a Holomonic mobile platform, and with some robotic. This is the top one is the collaborative robotic arm, which you are seeing here, and they have the magnetic. Magnum wheels also. So this is a special Magnum wheels. It can move in both XY direction. This is one of the plus they adapted additionally, and mostly it is a vision-based navigation and detection. So in order to plug and unplug the wall, unplug the wall socket, and moreover they have the some barcode encoder, so it will detect and it will plug it. Another question will come in your mind, how it will communicate with the electric vehicle. So for that only they have implemented the machine-to-machine communication and machine-to-server communication. So it won't work autonomously. It will be controlled by the server. Maybe some end user can control it, and with this communication paradigm, it allows the effective charging in the for the electric vehicles. Once the agriculture EV is coming to the garage, automatically it will communicate. The system will communicate with the EV. The agriculture EV, and it will plug in and it will remove the plug and will plug here autonomously, and then through server we can control that. And then once charging is over, it will unplug. So all the things is possible. So this is about the agriculture EV charging with the minimum robo. The another one journal I could see, automated robot-based charging system for electric vehicles. Here, this is also research level. They given some proposal only. It's something like proposal. So since we have a different type of socket, they are giving some common one. You can see that. So any vehicle can be parked here. There will be different type of charging station with the plug. It can the charging membrane magazine can move up, longitudinally here and there, and there will be a common gripper will be there in the roof mounted and hanging type. It will move this way and longitudinally and as well transversely, and there will be a gripper from the top. It will come down and will take out the charging plug from the membrane, and then it will plug to the vehicle. Once charging is over, it will get off. Once it is over, once it is plugged here, it will move to the other vehicle. It will do the charging. And moreover, this membrane also will rotate according to the vehicle condition. This is the proposal given one. It's a concept proposal given in the magazine. They given some mobile application also. How can do this? It's all about theoretical. And I could see the 3D vision guided robotic charging station for electric plug in a hybrid vehicles. Here, they have many interpretation. They use the shape-based matching and triangulation to locate and identify the charging port of the car or boat. It is to identify the charging port of the car and guide the robot and hold the charging cable and precisely plug in the charger. For that, they have a camera, exactly the clear camera vision sensor, and moreover, they have the different image processing to clearly identify to locate the this particular connector. So moreover, they use this to match the template. They use the Halcom machine vision software, so which is a well-proven, well-performed software where even the low contrast lights, how to control these challenges. So now slightly they come up, even though at low light, how to control the image processing to identify the connector and plug it. So for that, they use this Halcom vision software. Next one is the now you can see some of the automation which is available in the market. So far what we've seen is the institutional level. We can see some of the product which is available in the market already. You can see Volkswagen has a eSmart connector. It's all Kuga LBR based robot. So in here we need to park the vehicle near to this charging station. This Kuga robot will take out the charger from the charging station and will plug it to the vehicle with the camera sensing, and it is quite possible. But it's all fully developed. But here again, the constraints will be we need to park according to the position. And the next one is the Tesla snake type. Everybody knows it is there, and it is shown by the Tesla very long back. Still, there is no further information. What was the case for this? There's something like snake type. Already, I mean, always they are exceptional. They are the first one who made this kind of autonomous and automatic charging. After that, there is no information. What is that? So it is very clear that we can focus more on automation. And moreover, there are another one, the wall mounting type charger. Again, in Technical University at the Montreal dot mount at I think in German. So they started a project, and it's something like wall mounting robot for the plug-in unplug process. So another one is the Ford has the robotic charging for the disabled EV users. So mainly the prototype is built by the German Dartmouth University engineers at the lab. Finally, they installed in the real time. So here, so the vehicle will come, and the end user can easily identify through the Google map to the position. So once they reach the car parking with some right position, they can through mobile app, they can give the command to the this charging station. Then once charging command is over from this mobile app, then automatically the slider will open, and the charger will come out, and it will charge the vehicle. So end user can sit inside, or they can go out anytime. Once the charging is over, it will the charging will come out. Then the communication will go back to the mobile that your car is being charged. Again, they can end user can come and take the car. So this is the level of automation at the initial level they did. So this is the automation by the Samsung. This is I can say it is a version 2. The version 1 is a very old one, but this is the latest one. Here they did is something like once the end user approached the parking slot, there we have a connector in the pillar. They have to take the connector from their, they have to take out the connector. They have to plug it here in the vehicle, and they can scan the NFC tag in the pillar, and they can go out. Then automatically the communication will come from the through mobile application. This will come to this charging robot. Actually, this is not a robot. This is not only a robot, it's a robot with a battery. So through this, they can charge up to, I think, 25 or 50 kilowatt based on the capacity. So it is autonomous one, and it has the vision sensor and the object detection sensor, everything. So once the communication receives, you can see, then automatically it will move to the particular pillar. So while going, so it will see the NFC code. The machine knows, the robot knows which NFC code tagged pillar it needs to go. That he knows it clearly. It will detect all the NFC tags in the pillar. And almost you can see that it is detecting the vehicle object detection. Through this object detection, it is easily detecting this something vehicle is coming. Then when it approaches nearby, and automatically it will get stopped. It's ensuring the safety here. Once the vehicle is over, then it will move further. After that, this will come, and it will have a docking system here. You can see each and every pillar, there will be a small docking system will be there. This is what I explained in the first initial journal, the security robot, the same way. So we have they have a docking system. It will come and dock to the this pillar. In pillar, the small docking system will be there. Once it is docked here, through this, from the battery, from the docking station, the power will move to the. See, I shown you some different type of mode of connection, right? So maybe it's a third type, mode 3, I think. So this is a mode 3 type. This power is being transferred to the vehicle. So this is how the Samsung autonomous charging robot is working. It is in vehicle. I mean, it is in the product level now, lively. Now I can see the Doosan Robotics. It is based on the South Korea, even Samsung on the South Korea only. So here it's a Doosan M1013. It's an electric charging robot. You can see here we have one robot, and it has the vision sensor, and everything is here. And there is a common grip, magnetic gripper is here. There is the here is the that connector is there in the stand. So there is a conveyor is here. So when once the vehicle is reaching in the parking slot, there is a vehicle stopper is here. Once it gets stopped, the end user has to remove the cap, and they have to remove the vehicle cap and has a charging cap also. This is the minimum level end user work, and no need to carry the what is this? How to say connector. So here the end user work is reduced here. In the earlier one Samsung, I could see the end user has to connect. Only charging is autonomous, but here even the handling of connector also autonomous here. What is happening once they remove it through mobile app, they can give the communication to the this Doosan robotics. So automatically vision sensor will detect this. It will take out the from the gripper. It will take the connector. See that this robo has the human first. So whenever it's taking, it could be some vertical position. It cannot be used as it is in the vehicle. So for that, we have some alignment base will be there. In that, it is doing alignment, and then it is taking to the same angle. It is taking to the vehicle with the camera sensor, and it is detecting the and even a different light. See that in earlier gen we could see that. So they will ensure the effective light. Anyhow, they have advanced software here. Then here it will through image processing, it will detect the exact location, and it will plug it. It will achieve the plug. Once charging is over, it will unplug. It will give communication to the end user. So this is how it works. This is also in product level. Next one is the concept level. Maybe how long it will come, but it's in the concept level only. But this is fully autonomous here. There is no involvement of end user. In this case, the Volkswagen has implemented this. I mean, they're shown in the concept level. Very soon they will come up in the market. Here, once the end user park the car, they can give the communication to the charging robot. It is there in a common location nearby in a parking slot. You can see a series of robots. It is not a robot actually. Everything not a robot. They all three are batteries only. Is a batteries with plug. I mean the connector. This is a real robo. Whatever communication it gives here, it will reach this robo here. This robo will move out. It is again all the batteries are charged with the connector here. But this robo is like a security robo. What we see in the initially, it's a self-docking one. Once work is over, it will come here. It will come to his own position. It will dock here. It will get charged because it don't have any separate charging method. For other batteries, there is a connector is here. It's all batteries only with wheels. So once you get the communication to this robo, this will move, and it will attach this battery, and it will remove the plug from this socket from the charging area, and it will move to the vehicle. While moving also, it will ensure that is there any vehicle is coming, then it has a detection sensor also. If any object comes, then it will stop here, and then it will go move further, go to the near to the vehicle, and it will ensure the plugging to the vehicle from the battery connector. Once it is over, again it is back to his original position. See that once it is over, then it's charging to the from here. It is taking the this is one, this is the two. Once communication receives, it started working. See the blue color highlighted. Then it is taking the remove the connector from the charger and for the batteries, and it is moves to the fourth one is a vehicle connecting here. Once it achieved the connection to the battery to the vehicle, again it is back to this original position. It will dock to the original position. Once the battery is charged here, it will get the communication. Then again it will go. It will take out the battery from the vehicle, and again it will put all the batteries in the charging location. This is how it works. It is a fully automation. There is no human involvement. 100% automation by the robots. So this is what the Volkswagen has done. This is another one concept is the this is also a concept only by Doosan. This is what we see in the initial one. Some magazine, some of the how to say that journals, which is recommended the overhand collaborative robot, which can move horizontally, vertically, transversely, horizontally, right? So it is similar to that. So here the same, whatever is seen in the concept level or the institution level, now it coming to the product level. So this how. So we need to research more. So whatever we see, not today may be simple, in future it could be a product. So we need to focus on that particular area. That's the reason I'm differentiating in the institution level and research level, and further how it is reached as a product level. Here I could see here the same whatever I shown the journal, now it is coming to the concept level. In future it could be a product level. See that here the concept, here it has the overhanging robo. It has move in different direction, maybe a 6 or 7 degree of freedom. It will move in the roof hanging. For this is all for the heavy vehicle buses. So if each and every bus parking has the charging station. So now here you can see the along with the this robo, we have a separate camera is there. It will come and see the parking slot position. So it will this camera will check and ensure that the parking is correct. If it is correct, then automatically this nearest robo will come down. It will this coming to this position, and again it will this robo hand will come down, and it will see the position of the charging location, and it will get the alignment, and it will take out the charger from the charging station. It will put the charge. Once charging is over, again it is take out. So once it is put the charger, it won't be here for a long time. Again, it will go to other location. Wherever needed, it will do the charging. So when charging is over, it will come back and it will remove the charging socket from the vehicle and will plug it in the, place it in the charging station. This is how it works. This is also one of the concept I could see. Okay. So this is what so far we covered the importance of charging station, and what is the EV policy by the government and the both state and central government, and why we need automation. And second thing, the automation, how we evaluated. From the institution level or the research level, how it evolved to the product level or concept level. This is what we've seen so far. So I'm also doing research in this area. So maybe it gives some insight to you. That's the reason we people are doing many work, doing articles, journals. It maybe look like a small thing in the initial days, but in reality, very soon it will become a concept and a product in later on stage. So I think this will be useful for everyone. This is about from my side.
So thank you, sir.
Yeah,
thank you for your wonderful presentation. Okay. Participant, any question, you can post it in chat box. Actually, this session is very useful for us. Apart from the electrical, okay, what we can do as a automation engineers, we can implement. What way the automation is implemented in EV charging station. Very well, it's explained. Actually, there is a question from scholar's side, sir.
Yeah, okay.
Are the research gaps available in automated EV charging station? How they can do research in this automated charging station? Can you give some key points about that?
See, I told you very clearly, you need to see the what is the comfort and convenience to the end user. For any research, it should be towards the comfort and convenience. We need to have a full automation. Then only it will be useful. So whatever we seen today, some areas are fully automation and some areas are not fully automation. So we need to have a full automation. That is the research area. Okay, moreover, I cannot reveal more because I'm working in this area.
Okay, sir. Okay, thank you very much, sir. Yeah. Actually, this is a new thing we are learning. Actually, this automation, it's happening, we know, but this much it's grown up that we are not aware of it.
Yeah. Okay.
Yeah, nice and very useful presentation for us.
Yeah. Thank you.
Okay, sir. Okay, sir. No more question from the participant. Only that's a question we got it.
Yeah.
Once again.
Yeah, I think there is a question: is there any universal
It's
power
question.
charger? There is no universal power charger. It's a different type is there. Maybe in later on it may come even for the mobile. We have a three types. I don't know. It will take a decade, 1 or 2 decades to make a comment with it. It is not possible by today itself. Since the different type of rating to the battery, it is there. So if you standardize the battery and charging all, then it is quite possible. Nowadays, it's not possible.
Sir, one more question. What will be the real time constraint when we are planning to implement automated charging? So if you are going for automated charging, what is the time constraint, sir?
Yeah. What do you mean time constraint?
Real time constraints. Okay, what are the struggle we will get?
Okay, real time constraints.
What are the difficulties we will face if we are going for a implementation of automated charging station?
See, it will not be at a research level. We cannot address everything. We can go one by one. So definitely there will be there will be some constraint in the real time. So we need to approach one by one.
Yes, sir. Actually, also, if I'm going for automated charging station, this bus system that you shown, that is like a flash charging, it is available. How to track the particular charging port itself, it's a difficult task, I think. How to track the location of the charging connector, where it is available. Everything, it's a difficult task in the automated.
Yes. Through actually, this has been achieved by image processing only.
Okay, sir.
So through image processing only. That is the reason I could show initially some image processing journals. So without image processing, it is not possible. So everywhere image processing is important.
Okay, sir.
So with this only they are going to locate. So everywhere we have a camera, it will detect, it will match the image, and even for the even low light also it will match, and yeah, it will simulate and it will.
I think this is same like your the speed detection, right, sir?
Yes.
How they are detecting the speed of the vehicle.
Mainly with image processing only.
Okay, sir. Okay, sir. Thank you very much.
Thank you.
One more question. Recently, one more question it's posted. How the building process in automated charging stations, sir? Do you have any idea about this?
Already is there, no? In all the charging station, there is no online. I mean, it's not offline, online only. Even in Maramal charging station, they have to pay online only. Nowadays, we are get used with all the Paytm, Google, everywhere it is online only. So charging station, almost all the charging station is not almost all the charging station is well connected through online payment only. You have to scan it, then you will get all the company how much power is being charged, how much unit is being consumed, and what is the amount you have to pay. Then automatically you have to pay. Then only you can take over the vehicle, maybe something like that. But everything is online nowadays, especially for EV charging. There is no offline payment, even current today.
Okay, so thank you, sir. Yeah. Actually, there is a last question from participant. Do I need a special outlet at home to charge my EV? Yes, this is what sir is explained, the levels of charging.
Yeah, and moreover, in automotive, for example, if you buy any Tata Motors electric vehicle, so actually they are giving this facility at your home. If you recommend, definitely they will give. Actually, they are giving actually, but they will take some time, but they will give you some provision at your parking slot. If you give the space, then it will give you provision. That's what I told you. For that, to get the more benefit, you can get a new EB connection, and I can mention that it is for especially for the electric vehicle charging. Then you will get the domestic tariff.
Okay, sir. Thank you, sir. Thank you for your wonderful presentation, sir. Actually, we learned many things from your presentation. Thank you, sir.
Thank you very much. Thank you very much for all of your patience to listen to me, and thank you.
Okay, thank you, participant. The next session in today's is given by Mr. R. Venkatesan. It is about electric vehicle retrofitting and battery design, how it's designed. Okay, I'll give a short intro about. He has. I'll invite Yuvraj sir to give a short intro about Venkatesan sir. Sir, please.
Okay. Dear participants, the next session is vehicle retrofitting and the battery design. I am delighted to introduce this speaker. He is currently doing research in SRM University on the topic of bidirectional wireless charging for retrofit e-vehicles. He also has 10 years of teaching experience and 5 years of industry experience, and he published so many articles in reputed journals. He completed his UG and PG in reputed institutions, and he is very much proficient at converting conventional vehicles into electric vehicles. Currently, in our lab itself, we converted one conventional cycle and a conventional bike into a e-bike. Okay, so when I am just forwarding my talk to Mr. R. Venkatesan. Sir?
Yes, sir. Can you hear me?
You may continue, sir.
Introduction, sir. So, good morning, all. In this session, we're going to deal with how to retrofit IC operated vehicle into an electrical motor-driven vehicle, and also learn how to use a battery for your retrofitted vehicle also. Some overview of my presentation. Start from introduction and drivetrain, then components. What are the components there are used for retrofitting? Then basic operation, modeling of your vehicle. Then power rating selection, battery types. Then selection of battery ratings. And all is in the session. So, we may all come across this word retrofitting. Retrofitting is the process of doing a modification or the existing parts with the process. We will call it retrofitting. So as you see in the screen, so IC engine operated vehicle is active model vehicle. You can convert that into a electrical motor driven vehicle but by the process of retrofitting. So this is generally this is a process. Retrofitting is a process of converting an IC engine vehicle into a IC engine operated vehicle into a electrical motor driven vehicle. So if the government has made attractive policy for retrofitting or approval of retrofitting, if they give some attractive policy, means the retrofitting market will be have very huge opening in the EV industry. So because of environmental issues and price hiking of petroleum products and climatic change and uneven seasonal rainfalls. So all over the world, we are focusing on to the e-mobility instead of IC engine mobility. Before going to the session, let me know how many of you are having intention to convert your IC operated vehicle into a electrical driven vehicle. So please give your suggestion or give your opinion in the chat box. So if you are having a thought for converting a electric vehicle, converting a IC engine operated vehicle into electrical engine, you just put a yes in the chat box so that Okay. So if you wish to convert any electrical vehicle, definitely this is the right session for you. So before going to the retrofitting process, so we should know what are the components or what are the parts will be present in the retrofit vehicle. Start from drivetrain. Generally, it is a drivetrain model. Is a present inside the electrical vehicle. So generally it is driven by, as we know, it is driven by motor. So motor will be controlled, controlled by converter. So the converter will play a major role and motor will play a major role. Then the power source for the driving a motor is battery. So battery bank will be one of the major part. Then charging circuit, then transmission from motor torque to your wheels. So these are the main components or components for a drivetrain. So for converting an IC engine operated vehicle into a electrical vehicle, these are the main components we require. So these are the basic components for retrofitting. So battery, definitely this is the primary source for electrical vehicle. Then power converters, it will have fixed DC. This will direct from battery converter motor. So the motor motor LDC motor should be converter should capable to feed that motor. Then electric motor, as I said, we have different types of electric motor are there, VLDC motor, SRM, BMS, induction motor. So we have a lot of choices in the selection of electric motor. Then converter, the controller. So since we are dealing with e-mobility, so electric vehicle, we need to control the speed. So we need a controller that part will be played by this controller. Then transmission. So since we are using we have to transfer the car to the transmission. Then structure, overall structure of your vehicle drivetrain. So this is a real-time model of parts of retrofitting vehicle. So transmission, the motor, transmission, control placed in this vehicle. Diagram for, so these are the basic idea about how to convert IC engine into electrical. That's why I'm showing this diagram. Okay, so after knowing these basic components, once we have, if you want to convert IC engine or vehicle into electrical vehicle, you should select the motor. Proper selection of motor is required. So why we need a motor selection? Because so if you are having so much intention on the conversion, so we cannot use a high rated motor, and also we cannot use a lower rated motor as you see in the efficiency curve. So if the efficiency of motor will be on that, how much load you are utilizing the motor for. So if the load, your efficiency will be maximum in the graph. At 40% of load, your efficiency will be near 60%. If your load is 80%, definitely it will reach us more than 80%. If your load is 100%, your efficiency will be near 100%. So that is why we should motor which should be always low to 100%. So we need the protection of your motor. So if you want to convert your electric scooter into sorry, IC engine scooter to electrical vehicle, you should select a proper motor for your vehicle. So that you should perfectly choose the rating of your motor. So in the market, you have a lot of options for selecting a power. So once you decide the required rating for your vehicle, you can buy it from buy it from a market. The conversion kits are there depending upon your power requirement. So once you decide a power, you can buy a conversion kit. Okay, so for deciding a power rating, so what the power or what are the opposing forces or there you are driving a vehicle. So first you have to calculate the tractive effort. The tractive effort is a opposing force which will oppose the motion of your vehicle. So once you calculate the tractive effort and how much speed you are going to drive, then you can easily able to decide how much power you can require for retrofitting a vehicle. So first step in the dynamic modeling is finding out the retrofitting. Is a force required to pull the vehicle forward. This is a retrofitting effort. So once you oppose, you are able to oppose the effort. Definitely, your vehicle will start moving. We'll see what are the opposing forces which will be there for. Okay, so first we have to overcome these components. So first of all, we have to calculate the tractive effort. First part is rolling resistance. This is a rolling resistance is the opposing force, primary opposing force, which is caused due to the wheel and it's a friction, the bearing. So these are the major part in the rolling resistance calculation. So there's a formula to calculate rolling resistance. So M is the mass of your vehicle and G is the gravity, mu r is the resistance coefficient. So mu r, that is the resistance coefficient, is depends on the what type of wheels you are using, what type of that road condition of your where you are going to drive the vehicle. So these all depends on that mu r value. So here I have shown sorry. So here I shown some the constant, that's a coefficient of resistance, rolling resistance is there. So for car tires, concrete concrete type of roads, the mu r value will be 0.013. Similarly for gravel type of roads, 0.02. Then depending upon your road condition and your tire condition or tire shape, the rolling resistance, rolling coefficient will vary. So the constant values are given here. This is how we can calculate the rolling resistance. And next is aerodynamic drag. So definitely, if you are driving a vehicle, you will be opposed by your wind velocity which is present in the atmosphere. So this aerodynamic drag is definitely plays a major role if you oppose the moving of your vehicle very high in the air conditions, and then your driving force will be very more. That is why in this animation, this cycle during the driving of a cycle, if you reduce the opposing, that is the internal surface of your internal frontal area. If you reduce the frontal area, definitely you can minimize the aerodynamic drag, so that you can increase your torque requirement. So while you are designing any vehicle, you should care of reducing the aerodynamic drag. So for calculating the aerodynamic drag, we have formula that's FAD is equal to 12 rho and A CD under V square. V is a wind velocity, and it is a constant for calculating the aerodynamic drag, and A is a frontal area. So how much area you are going to cover in the front side if you are driving a vehicle. So this formula we can calculate the aerodynamic required for us. The next is the hill climbing. So hill climbing is also an opposing force. If you're driving a vehicle in the part of the slope area, or if you are going for a upwards, so there you have to calculate the hill climbing force. So generally, and according to the civil standards, our roads will not be inclination will not be greater than 45 degree. So depending upon the inclination, you can use this formula mg and sin. That's psi will be a inclination of your road. So according to the standard, this road inclination will not be more than 45 degree in the normal roads, right? Then acceleration force, apart from these all are opposing forces. This acceleration force depends on how much speed you are going to drive. So that will be calculated by this formula. So we have two acceleration. One is linear acceleration and angular acceleration. So linear acceleration is a acceleration it's coming from motor. Then angular acceleration should be transmit the torque produced in the motor into the wheels through some gears. So formula for calculating the angular forces, this is the formula, right? Therefore, total tractive effort required for this are sum of rolling resistance, opposing force, then aerodynamic force, then hill climbing force, then linear acceleration and angular acceleration. These are the opposing forces it should capable to overcome. Then only your vehicle will start moving. So once you calculate the tractive effort, so how you calculate the power rating for your motor is this a formula. So tractive effort is multiplied with the wind velocity of the vehicle. So if you are driving a vehicle at a speed of 40 km/h, means if you have to convert that into meter per second, it will comes around 11 meter per second. So similarly, you can calculate any kind of speed, how much speed you are going to drive. That is the velocity of your vehicle. That will be multiplied with your tractive effort. It will give a power rating of your motor. This is a simple formula to calculate how much power you required for convert your IC engine operated vehicle into retrofit vehicle. So here I shown some calculator for Excel calculator for designing a retrofitting or selection of power rating for the Activa scooter. So I have approximately I have considered 1000 kg as well as 1200 kilogram for moving a vehicle, right? So for 1000 kg, the width of your generally scooter frontal area will be 1 meter and 1.5 meter. So depending upon your vehicle dynamics, you can choose the width and height. Then rolling resistance, they have chosen the concrete road, so that I have chosen μRR as a 0.02, and air density rho will be 1.25. This is a constant, and a drag coefficient CD. This is for calculating the aerodynamics force required. Then gravity 9.8. Then how much speed we are going to drive, that is a 40 km/h I have chosen. Then frontal area for my chosen vehicle will be 1.5 meters square. So these are the values I'm assuming for designing or calculating the power rating of my vehicle. Then velocity, as I told, we have to convert that kilometer per hour into meter per second. Then I have chosen a hill climbing angle as 0 degree. I haven't considered that. I haven't considered the hill climbing force because I'm going to drive a vehicle in a flat road. That's why I choose. I haven't considered this. If you want, you can consider this one. If you are dealing with you are going to design a vehicle for a hill climbing and mountain ranges, you can calculate the degree also. So after using those formulas, what you have presented in the previous slides, so you can use these constant values and then use the formula and find out the value. What are the opposing forces or opposing power you require to drive your vehicle? So there's a rolling resistance. So for this 1000 kg, the rolling resistance will be 196 watt, and aerodynamic drag force will be 34 watt. So I want to consider a hill climbing since I have chosen a 0 degree, the hill climbing is 0. So total opposing forces here will be a 230.722 watt only. So since I'm going to drive my vehicle for a speed of 40 kilometer per hour, so I have to multiply this with speed required. You got to multiply the speed in terms of meter per second. So I am converted that 40 kilometer per hour into meter per second. That is 11.111. So once you multiply this, you will get 2563.5 watt. So my motor requirement will be 2.5 kilowatt. So once I decide this, we have to consider for losses, efficiency also this. For a domestic purpose, if you are using a vehicle for a domestic purpose means you have to add 25% of this value. If you are using it for commercial purpose, you have to add 50% of this power. If you are using designing a vehicle for a military application, you have to add 100% of your calculated value. So if I am going to use it for a domestic purpose or general purpose, so I have to add 25% of this power, 2563 watt plus 25% of total value. So similarly for a calculated 1200 kg also. So likewise, you can calculate what is a motor power rating for your vehicle. So once you calculate this, so we have conversion kits in the market. So it is available in a lot of ranges. So depending upon your requirement, you can choose the conversion kit. Is readily available with the converter, throttle. So complete set will be there. So once you buy, you can able to connect or convert your AC engine operated vehicle into electric vehicle. So this 800 watt hub motor. This is also 350 watt hub motor. This is a 250 watt chain drive motor. Then 2000 watt, so 10,000 watt chain drive motor. Similarly, for four-wheeler also available. So it is connected with differential wheels. So 3000 watt differential is there, and 7.5 kilowatt differential is there. So all are readily available in the online market. So this is a controller connection diagram. So once you bought that conversion kits, definitely there will be a terminals with some user-friendly indications or representation as there. So once you go through that, you can able to connect and control the motor. So it's a brake line, indication line. So everything will be represented in the terminal. So after deciding a motor, you should buy the motor conversion kit. Then you can start the process. So these are different techniques for mounting your motor into your vehicle. So this is a hub motor. The first one is hub motor driven vehicle. Second is a chain drive with without gear, and belt driven with some gear arrangement. So depending upon your speed requirement, you can control the gear also. You can increase the speed or decrease the speed with the help of gears. right? So up to that, once you brought conversion kits, you have to go for a battery selection. How much battery, how much capacity of battery you need for your driving your vehicle, that motor, right? So battery selection is mainly depends on the size, shape, and environmental condition, then life cycle, and also your budget. So budget of your requirements, right? So power requirements, then operating voltage, current. So these are the primary factors you should consider before selecting a battery. So these are the available battery we can use for a electrical vehicle. So first primary is a lead acid battery, then nickel metal hydride battery, then nickel cadmium battery. Then right now we are using lithium ion battery. So we have different types of battery cases. So depending upon these features of all the types of battery, you can choose proper battery for your application. So this is a main feature you should consider if you are choosing a battery for your retrofitting vehicle. So lead acid, this is a energy density comparison chart. So energy density means so per kg. So watt hour per kg. So for lead acid battery will be very minimum. So depending upon this watt hour per kg only, your battery weight and size of the battery will decide it. So if lead acid battery has a 50 means definitely it has a weight will be very heavy. So since it is a 50 only, so its weight will be very heavy. Even for a 20H battery, 12 volt 28 battery, it comes around 5 kg. So if you are going for a higher rated, if you're going for 56 kAh and 48 volt means it will comes around 50 to 60 kgs. So it will be equal to 1% traveling in the vehicle. So but if your vehicle is not, even if you are not considering the vehicle in the matter, weight in the matter means you can use a lead acid battery. If since we are using it for a mobility, definitely weight is a major concern. So whichever the motor have a higher energy density, it is a preferred one. So as from this chart, lithium ion battery have a very high energy density, so that weight will be very light. So as I said earlier, in case of 48 volt and 56 Ah battery, it will get a 60 kg I told, right? So lithium ion battery, it will give so nearly only 5 to 10 kgs. So almost it will reduce the 80%, 70 to 80% of your weight if you are replacing a lead acid battery with a lithium ion battery because of this energy density. Okay, so these are the specification or features of different kinds of batteries. So lead acid, as I clearly mentioned in the chart, it has a very minimum energy density, and lithium ion have very high energy density. Lead acid has 30 to 50, nickel cadmium 45 to 80, then metal hydride will be 60 to 120. That cobalt. So recently, so batteries are used for a electrical vehicle or commercially available in the market place. They are using lithium and cobalt type. Right. Then if you're dealing with the charging or designing a wireless charging or charging controller, you are going to design means that internal resistance is playing a very major role. So because if you are as I clearly mentioned in the previous sessions, that if you are designing a winding wireless coil for your charging facility, definitely internal resistance of a battery you should consider. So it will be around 152 milli ohm. For lead acid battery, it is very, very minimum. For 12 volt 26 Ah battery means it will comes around only 15 milliohms. But lithium ion battery, it has internal resistance will be a little bit higher than a lead acid battery. Then depending upon the life cycle, considering the 80% of charging and discharging, lead acid battery has 200 to 300 cycles, and compared to lithium ion battery, it is more than nearly 1000 cycles, 500 to 1000 cycles you can prefer. So when compared to lead acid and lithium battery, that life cycle is very much higher in case of lithium ion. Then depending on the charging time, lithium ion have a 2 to 4 hours, lead acid battery 8 to 16 hours it has. Then overcharge tolerance. So if you are going to design a charger, this is a major part. So overcharging tolerance. So in any case, if you are giving a charging current to the any battery, definitely it will accept. So you should stop the charging if it reaches the maximum limit. Otherwise, it will give some burst or fire in it. It loses its chemistry. In charging voltage, that is normal voltage for lead acid battery is 2 volt, and for lithium ion battery is 3.6 volt. Then cutoff voltage. So cutoff voltage is a voltage beyond this. You should not give charging current to the battery. So cutoff voltage for lead acid will be 2.4 volt. Then for lithium ion it's a 4.2. So once it reaches 4.2, you should stop the charge. So if you are designing a controller for a charging, you should take care of these parameters. Similarly, for discharging also, there is a cutoff voltage range. So once it reaches, you should cut off the discharge. So if you are continually discharging apart from this value, so definitely it loses its chemistry, and also the lifetime of the battery will be affected. Then last one is an important point, that is C rating. So how much current you can take from the battery, this depends on the C rating. So lead acid battery is available up to 5C, and for lithium ion it is available up to 30C. The cobalt will be available 3C. So nominal result, that's the best result will be available if you are using a lead acid battery at 0.2C. If you are using a 100 Ah battery, means you should load this battery for a 20 amps only. So then only it will we can get the full life cycle of the battery. So that is why very big drawback when compared to a lithium ion to lead acid battery. Definitely, if you are purchasing, if you need a 50 Ah, means you have to buy a very much high rated battery. But in case of lithium ion, it can able to give a full current. So if you want a 5 ampere current, means you can able to buy a 5 Ah battery. So that is enough. Then temperature handling capability of each batteries, it will be higher in case of lithium ion battery. Okay. Right, once you choose that, depending upon the features you required, chosen the battery, then you have to decide the voltage, how much voltage we have to operate the battery. So as clearly mentioned in the chart, so if I'm want to decide select a battery for a 3000 watt, if my voltage is 36, I choose a voltage as 36, current will be 83 ampere. Similarly, if I'm for a same power voltage, if I increase the voltage from 36 to 72, the current is often 41.67 is coming. Similarly, if I increase the voltage to 200 volt, current will be 15 ampere. For same power rating, we are getting the operating current, different operating currents. Okay, so once the current rating is decreased, the connection requirement and the wiring harms, we can decide at very minimum rating. So that is why voltage selection should be optimum. So it should not be very much less as well as it should not be very much high. So if you are choosing a 3000 watt motor, nominal voltage, perfect suitable voltage will be 72 voltage. Okay. So once we decide a voltage rating and a select type of a battery, we have to collect what's the power rating required. So it depends on the range, how much range. So like mileage in case of IC engine, we'll call range in case of electrical vehicle. So range means so for per charge, how much distance your vehicle will travel. That will be given by the range. For finding out the range, if the range is increased, definitely you have to go for a higher rated battery. So it will be conflict between price and range. So for calculating the power battery rating, so travel factor we have to calculate. So travel factor is equal to total range, that is a total distance you will cover for a per charge, that is a total range, divided by how much speed you are going to drive your vehicle. So that is given by travel factor, total range divided by total speed. So total range or consider at my total range as 200 kilometer per charge, and at a speed of 5 to 50 kilometer per hour means, so 200 by 50 will get a 4. So travel factor will be 4. Then motor power rating. So there is a motor power rating. I have consider 1550 means. So you have to multiply this with travel factor. We will get the exact power rating of your battery required. For driving a 1000 watt motor, once for a single charge, if you need a 200 kilometer range at a speed of 50 kilometer means, you should choose 4200 watt of battery. So similar to the efficiency of your motor, so battery also has some efficiency. So for lithium ion battery, the efficiency will be 85 to 93% while charging and discharging. So you should consider the efficiency also. So while considering this 85, taken as a white case, I have taken 85%. So battery capacity will be increased to 4.94 kilowatt hour. Similarly, for a motor also have some efficiency, so we have to consider that also. So 4.94 divided by 0.85 comes around 5.81 kilowatt per hour. So this is how I can choose a motor power rating as well as a battery rating. Therefore, for driving a vehicle of motor power rating of 1000 watt for a range of 200 kilometer at a speed of 50 kilometer, I need a battery capacity of 5.81 kilowatt per hour. Okay, so these are the battery stacks presently using for electrical vehicle that four-wheelers Renault are using. All over the world, nowadays they are using lithium ion only. So this is a battery capacity of those vehicles and models. Okay, so right now we have decided how to select a motor power rating and how to select a battery rating for driving that motor. So once you decide a power rating of your motor, you should able to have to consider the C rating as I said earlier in the specification. So C rating is depend upon how much current you can taking out from the battery. So if this is a 1C rating, you can take the full current of the rated ratings. So if the 10 Ah battery has a 1C rating means we can take 10 ampere of current for an hour. So similarly for 2C, if there's a 2C rated battery means you can take a 20 ampere of current for an half an hour. If it is a 4C, 3C means you can take of 10 amps. Likewise, you can multiply the current and also how much time duration it will give, that will be reduced. Okay. So this is how we can stack a battery. So lithium-ion battery, as it said earlier, each cell should be stacked together. So each cell voltage will be 3.7 for lithium cobalt type of lithium-ion battery, that is 3.7. If you want a 7.4, you have to, this is a basic in the electricals. If you want to multiply the voltage, you have to connect it the battery in the series. So depending upon your voltage requirement, we can stack multiple number of cells in the series so that we can achieve our required voltage. So if you want to increase the current rating, so you have to connect it in the parallel. So if it is a 3.7Ah lithium-ion cell, if you connect two cells, you'll get I'll get 7Ah. Similarly, if you connect three cells, I'll get 10.5Ah. In this way, you can achieve our required voltage and required current. So these are the term fixing arrangement. So linear packing and offset packing, so that we can reduce the compact size of your lithium battery stack. So these are the components required to stack a battery. This is a cell holder. Then for connecting a series parallel connection, we need the nickel strip. Then this for epoxy sheet for protection of your lithium-ion battery stack. There's a spot welding machine you definitely need for getting the connection between the cells through nickel strips. So this is the retrofitted vehicle in our lab. So 300-watt electric bicycle and 1000-watt electric bike here did in the research lab. Okay, thank you. So any questions you can ask now.
Any questions from the participant? Audible, right? Thank you, sir, for real time what it's going on, how the conversion, everything clearly explained from your presentation. So we understand everything. Most of the part you covered about batteries and how the conversion is done. Everything is explained. Also, few questions from the participant side. 1 second, sir. I'll read the questions. Please clarify the participant doubts. Yeah,
So is there any retrofitting facility?
the first question, what are the research gaps available for retrofitting the electric vehicle, which can support the academic and scientific community? Then how we can address the retrofitting for by research? That's the first question, sir.
Okay, so right now there is no standards or for retrofitting is not there. So framing the standards is a very big task. Then designing a aerodynamic. So for
Okay,
framing
next question.
a big task.
Okay, sir. Next question. Which is best? Okay, whether if I'm converting the retrofitted vehicle, either completely I can convert it the electric vehicle, pure electric vehicle, or I can convert it as a hybrid mode, which is best choice.
Okay. So in my point of view, if you are converting a completely into a IC engine vehicle into a battery operated vehicle, that is a bad choice. So if you are going for a hybrid, then it will be a good choice. So because considering your petrol price or fossil fuel price as well as battery, right now battery cost will be almost higher than your petroleum cost. It's almost near, both are equal. So if your battery cost is getting minimized in the future, definitely you can go for a pure EV. Right now, my choice is don't go for a pure EV. Hybrid is a very perfect choice.
What about the battery accidents, sir? Which battery is safer?
So researches are going on in that field. So right now, fire accidents have happened in cobalt type of lithium and type of batteries. So recently, most of the electrical vehicles are switched over to lithium phosphate. So LPF type of batteries they are preferring. So in that energy density will be a little bit lesser than lithium and cobalt type of batteries. So that recently there is no accident in LPF type of batteries. In our lab, we are preferred electric cycle with the LPF battery.
So the next question, uh, is it better to go for higher kilowatt motor for two-wheeler for carrying heavy weight? For example, two-person or heavy person can be travel. Okay. What is your opinion? Which is better? We can have a higher kilowatt motor. What is the maximum rating we can choose for that?
So yes, I given and motor rating selection. If you are going for a motor, designing a motor power rating, definitely you should consider what purpose you are going to use, what purpose you are going to retrofit your vehicle. Whether it is a general purpose, you have to add 25%. If you are using it for a commercial purpose, you have to add 50% of your vehicle. So you should perfectly select the application, then you go for a retrofitting. If you are designed it for a commercial purpose, if you are using that for a general purpose, definitely you will lose some energy because of that efficiency will be very high only at full load. If you are using a commercial vehicle for a general purpose vehicle, definitely you will lose. So first you decide the application, then you go for a retrofit. So you cannot design a vehicle which is suitable for all the applications.
The next question is to about government policy. What is the government policy? Is there anything is framed for retrofitting?
So as I said earlier, there is no policies from government is for government for retrofitting. Right now, they are given permission to retrofit the IC engine operated auto. So auto into electrical vehicle, electrical motor driven autos. Right now, they have framed some policies only for auto that is three-wheeler only. They haven't framed any standard for that is scooters or four-wheelers.
The next question actually, uh, you are doing a stacking. Okay, apart from the battery, we are purchasing outside.
Okay.
Battery pack we are purchasing outside. We are stacking a battery. We need to test the internal resistance of the battery. Then what is the effective stacking? How this resistance measurement will infer or it will give a effective way of stacking.
Okay. During charging, your charger will be designed by calculating the internal resistance of each cells inside the battery type of the battery. So once you decide the stacking of a battery, the resistance of the each cell should be same. So if the resistance will be uneven, definitely a charging we are going to charge the vehicle through a BMS. So it will be apply a same voltage to the every cells. So if the resistance are differ, the current flowing to the cells will be also differ. So some cells, if the resistance of internal resistance of the each cell vary from 1 to 1, so current passing through that cell also varies. So its temperature will be the current is more, temperature will be more. Definitely that imbalance in the temperature will occur and leads to accident. So we have to calculate internal resistance properly if you are stacking battery. Even though if you are using a battery management system, you should taking care of internal resistance during stacking of the battery.
Okay, sir. Thank you, sir. Actually, before moving to the next question, actually the question, it is a retrofitting facility available at your premises. Before asking this question from your side, I'll raise these questions to the participant. So the participants can, you can raise up your hands if you have done any conversion, or if you developed a battery stack, you can share your experience. You can raise up your hand, so we will unmute you. You can share your experience. If you are converted any vehicle, or you have done any battery stacking in your laboratory, we can discuss about that here. Okay, sir. Sir, you can give your opinion on the question. Meanwhile,
Okay, in our
about
premises,
retrofitting facility.
we have all the facilities like how to stack our cells. We have a in tomorrow's session also we will deal with that, how to stack a battery. Then we have facility for spot welding, and we have components. We have a cell balancing equipment. We have for battery stacking. We have, and the retrofitting. We have a fab lab, fabrication lab is there, so we can give assistance for.
I think many more questions are available. I'll limit the questions. We will come to the practical section. That time we are explaining about retrofitting only. Most of the case we are explaining about retrofitting. That time we will clarify your doubt how to convert, how to get a RTO clearance, then how to what are the questions related to the battery conversion. I will read out little later. We will discuss during practical section. Is it possible to convert existing bullet into electric vehicle? I think I can answer this question. It's a question also, it's more related. Actually, the vehicle which we are going to convert, that is important. Then which motor we are going to use, which motor or how much battery capacity we are going to use. The structure only will vary. If I'm converting any scooter mechanism, or any bullet, or any other recent vehicle, only the vehicle structure will be varied. But we are going to connect it, our motor, to the wheel. Okay, that we with gear or without gear we will connect. That mechanism is same only. If I'm using a scooty or a bullet, it's same. But in the scooty kind of mechanism, we can go for a hub motor. But it is not possible if I am using a gear vehicle. It is not possible directly. It is difficult. The hub motor with wheel size, it is very difficult. Some wheel size it's available, but it's not that much kilowatt. Actually, that is not that much power carrying capacity. It is little difficult. Sorry, from my side. Okay, so thank you, sir. Thank you for. Any other questions or any suggestions? Any participant they are willing? Anybody willing to share your conversion experience? You can share. You can raise up your hands. One participant, I think. I don't know who's that participant. I'll unmute him. Okay. Murugan B, I'll unmute you. Sir, I think you can.
Good morning. Good morning, sir. So Venkatesh, the good presentations.
Yes, sir.
Hello. Yes.
Yes,
Okay.
sir.
Okay. Okay. Actually, I'm working on a battery management system, sir, for battery pack.
Okay, sir.
And first, I purchased the Komaki vehicles,
Okay.
and that battery pack contains 72 volt and 30 amps.
Okay.
Initially, I worked
Sir, you are
with.
from industry or sir? Sorry to
I am
interrupt
also
you.
research scholar, sir, in the instrumentation department, SRM IST.
Oh, okay. Okay, sir.
Okay. Okay. If we start with the big one, we are struggling. So we start with small battery packs, for example, 14 cells. Now I change a 24 volt and 5 amps. If we start with small one, it will be a good experience for those who are doing research.
Sure, sir.
Initially, if we take 72 volt and 30 amps, means what are the sensors we will take. So I struggled a lot.
Okay.
So start with the small things, then if we go bigger one, it will be easy. Battery pack design. It's my experience.
So, okay, if you are considering all the factors and testing, what are the testing you should do before stacking, if you doing those things perfectly, definitely we can stack the battery with the higher rated also.
Yes, sir.
That cell balance you should follow, then the internal resistance should be perfectly a match from cell to cell. Definitely you
Yeah,
can
I'm concentrating on that state of health algorithm only.
okay.
Yeah.
Okay, sir. Thank you for your opinion.
Okay, sir. Okay. Thank you, sir.
Thank you, sir. Thank you, participant. Okay. Okay. Tomorrow we have a physical section. Okay. That time we will more discuss about the conversion. What is the battery we are using? That we will explore here. Please come and join with us. Okay, with this, I'll complete the today's section. Thank you all. The feedback link is shared in the chat window. Please fill the feedback. Thank you all.
Speaking